Good evening and good morning, everyone. My name is Abhay Agarwal, and I have been in the IT industry for almost 20 years now. So, agenda for today is what is Python? Python is a programming language. We all know why Python is so popular in today's world. Why Python is offered by many universities. Python with data science, machine learning with data science. A lot of university courses are there, and Python is really hot for the last 2 or 2.5 years. And why Python is so popular? We are going to discuss that. What is predictive analytics? We are going to discuss in detail. What are the applications of predictive analytics, steps involved in predictive analytics, and what is predictive analytics using Python, and why Python only, why not any other programming language? We are going to discuss that, and we'll do some kinds of hands-on in terms of what strategy we follow in terms of predictive analytics. So what is Python? Python is an open source. We don't have to pay any cost for it. That is one of the benefits. In the older times, if you remember, like if you might have worked on SAS is a data warehousing tool, and company used to spend millions of dollars just to procure the software of SAS. So SAS is a data warehousing tool which was very popular around 8 to 10 years back, and company used to spend millions of dollars just to acquire it. So Python is an open source. It is easy in syntax. Syntactically, it is very easy. Number of lines of Python is one third the number of lines of code you write in any other programming language. For example, you write 100 lines of code in Java or C++. You just need 33 lines of code to get the same thing done in Python. Python has got 65,000 libraries. Libraries are nothing but the header files which we include on top of our code. Like for example, math is one library, and you can use math dot. I'll show you a small demo. So I have installed Anacondas. Anacondas is a basically a software uh, which comes with a tool called Jupyter Notebook, wherein we type all the Python commands. So there are many ways of doing it, but Jupyter Notebook is one of the popular ones. So let me show you one example for it. So I'm going to create a new notebook. So this is the interface where we write our Python code. So people new to Python, they might find it's difficult to understand, but for the timing, just understand we have a software called Anacondas. Once you install that, we get Jupyter Notebook. Notebook is same like a notebook that we used to carry in our school days, and we have pages there or cells there where you write down the commands, and it automatically get executed, and you get the output there as well. So whatever the inputs you are going to give, what are the commands you are going to give, the output you are getting on the same page. So it's an integrated development environment. So this is a cell where you write anything. So you write print hello. Suppose you write print hello, you get output as hello. So it's taking some time to load. So its kernel is starting. So it's a interface which is connected to Python, and Python is a both interpreted and compiled language. And once you write down any command, you get executed. Suppose you write a equal to 10, b equal to 20, and you print sum of a and b is a plus b, you get the results. Similarly, if I import a math library and I say math.py, you get a pi value. So math is one of the libraries. Libraries are nothing but the header files which you include on top of our code, and you can use these libraries to get the work done. So Ahmed is saying Python is a programming language, has many libraries in data science. It is easy to learn language, especially in AI and Ansible professionals. Yeah, you are right, Ambati and Ahmed. So Python is a programming language which is a very high level programming language. It is an object oriented programming language. We can do all the data analytics in Python. So Python picks up importance because of three major libraries like pandas, NumPy, Matplotlib. So Panda is a library for data analytics. NumPy is a library for numerical analysis. And Matplotlib library is for plotting graphs. So these are three basic libraries which made Python really popular. So in pandas, you can do all the data wrangling step like data munging, cleaning, joining, concatenating, filtering out any records. So Panda is a library for data analytics. NumPy is a library for numerical analysis for any kind of a statistical problem like kurtosis, like p-values, z-score, mean, median, mode, any kind of a statistical operations can be achieved through NumPy. Integration problem, differentiation problems can be solved by NumPy. Matplotlib is a library for plotting graphs. You can plot histograms, pie chart, bar chart, any kind of a graphs can be plotted using Matplotlib. So these are the three basic libraries because of which Python picked up its importance. And Python is a language which is very versatile. You can write on a Python code in MacBook and you can transfer that code in Unix machine. From there, you can transfer it to Linux machine, Linux to Ubuntu, Ubuntu to Solaris. So it's a platform independent programming language. As I told you, one third the lines of code you need to write in Python. So lesser the programmer suffered, lesser the coding he is going to do, lesser the debugging is required, lesser the storage space is required. So Python is very powerful language in terms of data analytics and any kind of a field you can think of, by like bioinformatics, like connecting to AWS server, doing data analytics, doing machine learning. So all these things can be done through Python quite easily. So let's come back to the presentation. So what is Python? Python was created by Guido von Rossum in 1989. So you can see it's a very old programming language, but because of these three libraries, NumPy, Pandas, and Matplotlib, it picks up its importance. And all the big companies you might have seen, like Google or Facebook or Yahoo or Twitter, they have been using Python for last 10 years. And they were using Python quite extensively. And that is the reason they are market leaders, because they were not paying any cost for procuring the softwares. And it is a quite old programming language, but in 2007 or 2008 it picks up the importance because of these libraries, and for the last 10 years it has been matured to this level. Inspired by his favorite show Flying Circus, creator is Monty Python. It is a general purpose, high level interpreted language with easy syntax and dynamic semantics. Interpreted means line by line execution. Suppose there are 100 lines of code and you have some error on the 90th line, so 89 lines will run fine, the code will stop on 90th line. So it's a both interpreted and compiled environment. If you write down a single line of code, it's working like an interpreted environment. But you have, let's say, 100 lines of code, it works like a compiled programming language. It checks the syntax in the whole code and runs it. What are the different features in Python? If you talk about features in Python, we can talk about simplicity. It is more like an English language. The syntax of Python is more like an English language. It is not having very difficult diagrams, or it is not having difficult keywords to remember. So it is very simple in understanding. So Python is designed in such a way that you can think more of code and less of a syntax. So syntactically, you don't have to worry a lot about Python. Then it's an open source. Again, you don't have to pay any cost for it. You can easily download on your laptop and get it installed and get the work done. It is very much portable. You can transfer your Python code from Unix to Linux, Linux to Solaris, Solaris to HPUX. It is embeddable and extensible. You can embed your Python code in C++ or C programming language, or you can embed your C++ C programming language code into Python. There are libraries like Jthon, there are libraries like Cython, which helps us to integrate our C++ code with Python. It is very much interpreted. As I told you, it's executing line by line. Suppose you have 100 lines of code, till 99 lines, it will work fine. If you have syntax around 100th line, it will stop over there. So it's an interpreted programming language. And it has got importance because of the huge number of libraries like NumPy, Pandas, Matplotlib, and sklearn. Sklearn is for machine learning. Machine learning is nothing but predictive analytics. So Python picks up its importance because of these three major libraries. And it is very much object-oriented programming language. So all the concepts of OOPs like inheritance, polymorphism, encapsulation, all these concepts are already there in Python. So what is predictive analytics? As I told you, when we are trying to forecast the future based on historical data, it is known as predictive analytics. So in terms of predictive analytics, if I talk about definition of it, analytics that helps us to forecast future performance and results. And I told you, why do we need that? Just to increase the business, just to improve the business, just to improve the profits, just to mitigate the risk. So we are doing a lot of analytics in terms of what is going to happen in future. So what are the different steps of it? First of all, we have some problem statement in mind. Suppose you take an example of a Ola cab. So let's say the Ola company, when it started, they are thinking of making this app. So they were having some problem statement that there are customers, there are cab drivers, how to link them, how to make the customer directly reach to the cab drivers. So there is some problem statement in hand, what needs to be done. Then we collect some historical data, what happened in the past. So we collect historical data, how customer was booking the different cabs, and how many cabs were booked in a state in a different areas, how many agents are there, how they are doing the cab booking, whether they are doing telephonic call or whether they are doing online. So they do a lot of data collection. So data collection helps us to analyze what was happened in the past. Then we clean the data. So many times it happens that my friend booked the cab for me 10 days back, and the cap did not reach. So it's a kind of an outlier, which is not which we do not want. So we are going to clean the data where we are actually interested in some kind of a records. Data cleaning means data removing the outlier, removing the correlation between variables, finding the variance between the variables, finding the records which are not going to help anyway, some missing values we need to remove. So data cleaning means preparing it for next step, that is data analytics. Then we analyze the data. How many cabs were booked in a day? One passenger is booking cab how many times in a month? What was the average tariff cab driver is going to charge, is charging in the past? Whether the payments made by the customer are made by credit card or debit card or cash? How many cabs are running in a particular time frame, let's say 12 a.m. to 4 a.m. So we are doing a lot of data analytics, visualize it through graphs, figure it out how data is behaving in the past historical data. And then based on that, we are going to pick up some model, maybe linear regression, maybe logistic regression, maybe decision trees. So these are the inbuilt algorithms which are statistically driven. So all the machine learning algorithms are driven statistically in the backend. So we use some predictive model which is already there in sklearn library, like linear regression, like logistic regression. Once we use that model, we validate the model whether it's predicting well or not. We do cross validation. We pick up some records and test it using the model whether they're predicting right or wrong. Once the model is very much accurate, we are going to deploy it for the future use. We are going to deploy it on the server so that next data is going to come, we are going to predict it. So these are typical steps in any of the machine learning or predictive analytics kind of a scenario wherein we collect the data, we clean the data, we do a lot of data analytics, we find the trends and the hidden patterns in the data, then we do the predictive modeling using some algorithm, and then we validate the model whether that algorithm is working fine or not, and then finally we are going to deploy it for the future use. Now, what are the applications of predictive analytics? If I talk about what are different areas where predictive analytics is getting used, some of the examples I have given you: Ola cabs or Uber cabs, Amazon is one of the example, Netflix is another example. So predictive analytics can be help in future predictions, that helps in numerous businesses. Like it can help in promotions. Definitely you are going to pick up some market where you're going to pick up some promotions. So let's say you are manufacturer of a car, and you manufactured a car which is a very expensive car, more than 25 lakhs, and you want to promote it. So you are not going to promote all over the country, it is going to be very expensive. So what you're going to do, you are looking for every state, some posh area in the particular state where rich people are staying, and you will put big hoardings in those places and do the marketing. So based on the historical purchases of the data, the purchases of the car, so all the rich people, they are buying more than 25 lakhs car in the particular area. So you are going to do the predictive analytics, what next area is going to be more popular for this kind of a car, and you do a lot of promotions. Similarly for the pricing, if you go to Amazon, if you go to Flipkart, there are different days where the discount is more than 30%. Why they do this? Because they know it's a festive season, people are going to buy a lot of things, they offer some discounts on the most likely products people are going to buy. So they do a lot of predictive analytics based on historical data. For example, in the last year Christmas, chocolate sales was almost 10 times as compared to the year. So all these websites are giving heavy discounts on the chocolate so that people are going to buy from their websites. So they do a lot of predictive analytics based on historical data, what next customer is going to buy in the upcoming time. Demand planning, so depending on the weather conditions, depending on the economical state of a country, depending on the purchasing trends, people are going to predict what is going to be the demand in the upcoming times. The best example is the COVID time. So when the COVID actually started, you might have seen the sanitizers were shortage, we were having a lot of shortage. And at the same time, a lot of companies predicted that the sanitizer is going to be required almost everyone in the country, and a lot of startups came where a lot of sanitizer making companies came into picture, and they started developing or manufacturing sanitizers. So based on predictive analytics, what next people can demand, people started their own businesses and become entrepreneurs, and they are doing well. So based on predictive analytics, based on historical data, people predict future and they take some actions today. Campaign management, for example, marketing campaigns, sales campaigns. So companies do a lot of marketing campaigns in terms of increasing the sales by looking at the historical trends. For example, if a company founds that in summer my AC sale is going to be very much doubled, it do promotional campaigns in the winters itself, that if you are the first customer to buy the refrigerator or air conditioner, we are going to give you this much discounts. So based on the historical purchases or trends, companies are doing a lot of campaigns. Customer acquisition. So based on the purchase trends of the customer, companies are offering a lot of discounts or a lot of offers. Suppose I am a person having a good debit and credit balance in my bank account. My bank is going to definitely offer me a credit card. Why? Because they know if I am having a good earning and good spending, definitely I'm a valued customer for the credit card, and they offer me a credit card. So based on analytics, based on predictive analytics, they're going to give me the credit card. Budgeting and forecasting. So depending on the economic condition of a country, depending on the situation, what is going in the market, the government and as well as the private companies are doing budgeting and forecasting for the upcoming year. Fraud detection. Definitely, suppose you're using a credit card and your credit limit is 20,000 of the card, and if you swipe it for 1 lakh, what happens? Automatically you get the call from the bank that are you the valid customer or not. So fraud detection is again one of the applications of machine learning. Based on the historical data, system understands what is fraud and what is not, and if some malicious thing happens, system triggers that this is a fraud. So these are the applications where predictive analytics is heavily used. Now, structure of learning in Edureka. If you talk about structure of Edureka training, so the first step is introduction to Python training. So you'll get some basic Python training where you'll discuss, where you'll learn what is Python, what is data analytics, and what is list, what is tuple, what is dictionary, some basic data structures in Python. You will understand what are regular expressions or wildcard characters or searching patterns. Then we'll talk about object-oriented programming, where we discuss about what is class, what is object, what is inheritance, what is encapsulation. Then we'll talk about different type of looping structures as well, wherein while loop, for loop, if loop. Then we'll talk about different data structures in terms of sets, data sets, dictionaries. We'll talk about pandas, numpy, matplotlib, some libraries for data analytics. So introduction to Python training is the first step, and anyone can learn it. There is no need of no need to be experienced guy in this. You don't have to be having programming experience in this. Even in 12th standard in today's world, in CBSE board, Python has been incorporated. So Python is an easy programming language. Even a 10th standard or 12th standard candidate can learn it. So even if you're not from a programming background, you're from manufacturing or you're from chemical background or mechanical background, you can easily learn Python. Only thing is some logical attitude is required. It's a very easy programming language syntactically. So introduction to Python training is the first step for this. Then there are a lot of hands-on exercises which is delivered by Edureka. So instructor who is going to take your classes is going to give a lot of in-class exercises as well as off the line. As an homework, you'll get a lot of exercises to get it done. Some real-time problem statements which you'll be solving on your own. The next step is sequence and file operations. So once you're having an introduction to Python training where you understand what is Python and why do we use it, we have some data structures in Python like list, tuple, dictionaries. So that is going to be discussed in this. Then a lot of hands-on in this list, tuples, and dictionaries. Then third step is deep dive into functions and operations. So these are the backbones of Python. So functions are nothing but a portion of a code which can be repeatedly used again and again. So let me show you what exactly a function is. So if you write down a small code in Python, let's say I write a small code in Python which is adding two numbers. So let's say I define a function def fun, and I say print hello. And if I call this function fun twice, you can see hello is printed twice. Let's say I define a function fun and I pass two arguments a and b, and I say c equal to a plus b, and I print sum is c, and I call this function fun with 10 and 20. So this is the function definition where def is a keyword, fun is the name of a function. It takes two variables a and b. A collects 10, b collects 20, c gets a plus b, that is 10 plus 20 is 30, and it prints the answer 30. So this is the function. Let's say I run the same function for different input. Let's say I run it for 11 and 21, and I run this function again for 22 and 33. I get three outputs. Some is 30, some is 32, some is 55. So you can use the same function, can be reused again and again with different inputs, and that's a benefit of a function. Function is nothing but like a juicer mixer grinder. You put tomatoes into it, you get a juice of tomatoes. You put apples into it, you get a juice of apples. And the functionality of juicer mixer is to grind it and get the juice out of it. And that is what this function is doing. Whatever the input it is going to do, it is going to do the same operation on it, that is adding it and returning it to you. right? So function is something very important in in Python, wherein a lot of things we write down through functions. And why do we need functions? Just to reduce the number of lines of code. If I would have to add these numbers, I would have created A, B, C, D, E, F, six variables. But I have taken only two variables, A and B, and get the work done. So it is decreasing the complexity of the code. It is increasing our efficiency of the code. It is making our code more modular, more readable, more structured. Suppose you are working in a telecom company, there is a tariff department, there is a KYC department, there is a billing department. So everyone is going to write their own functions and we can reuse it. So that's the benefit of functions. Similarly, in object-oriented programming, we have concepts of classes and objects. Then there are a lot of hands-on pertaining to it. And then as a fourth thing, we are going to work on exception handling. Exception means trapping the errors. So let's say you divide any number by 10, or sorry, 0. Suppose you have some number 10 divided by 0. What do you get? You get an exception, zero division error. You cannot divide a number by 0. So this is an exception. Exception means error. So how to handle it, how to trap it, how to gather it so that you will not get this kind of an error. That is known as the exception handling. So in Python, we have try block, else block, finally block, except block, which is helpful in trapping these errors so that end user will not get this kind of error. Suppose you build a big software and the software is dividing two numbers and you give second number as 0, then the software is going to pop up this kind of error, which will not give very good impression about you. So what you'll do, you'll use exception handling to trap this kind of error so that end user will get a valid message that you cannot divide a number by 0 rather than this traceback error of Python. So exception handling means trapping the errors and taking some corrective actions. And that is the part of Python only. We have exception handling. Then we have introduction to NumPy. NumPy is a library for numerical analysis. As I told you, integration problem, differentiation problem, linear algebra problems, Fourier transformation, optimization, statistical interference like standard deviation, like variance, like kurtosis, like p-value. Suppose I import NumPy. And NumPy has got a concept of array. Suppose I say array equal to NumPy dot array, and I pass some numbers 1, 2, 3, 9, 8, 33, 44, 55, 11, and I print NumPy dot mean of array. So we'll print the mean of these elements. Mean means average. Suppose I print NumPy dot min of this array. We get the minimum element. If I say print NumPy dot max of this array, I'll get a maximum element. I'll say print NumPy dot standard deviation in the array. So this is standard deviation in the array. So you can use any kind of a statistical and mathematical expressions to get it done. So in just one line of code, we are to find the minimum element, maximum element, standard deviation, mean element, mean of this particular NumPy array. Similarly, we can find all statistical characteristics like variance, kurtosis, p-value, z-score. All the kind of a statistical operations can be done through NumPy. It is a very flexible library which can deal with multi-dimensional data. Suppose you have image has got red, blue, and green pixels. So it can cater this kind of a data, and for deep learning, it is very helpful. Deep learning is again subset of machine learning which is dealing with images. So when you're dealing with images, machine learning algorithm fails because machine learning algorithm can handle two-dimensional data, but deep learning can handle multi-dimensional data. So in deep learning, we use multi-dimensional data and we use NumPy arrays quite extensively. So NumPy is an important library for any kind of a numerical analytics. Then comes the next library for data manipulation called Pandas. Pandas has got data frames having two-dimensional data like rows and columns. So you have data in a form of rows and columns. You can filter any records, you can concatenate any records, you can do joins, left join, right join, inner join, outer join. You can do selection of a particular records, you can filter out, you can find the outlier, you can find the correlation, you can create the heat maps. So any kind of a data manipulation activity that you might have been doing through SQL or any kind of RDBMS language, RDBMS databases, it can be done through Pandas with an easy syntax. Then comes the next thing is data visualization, that is plotting the graph. Suppose you want to plot a histogram or a pie chart or a bar chart. Any kind of a plotting can be done through matplotlib. Similarly, you can have GUI programming. There's a library in Python called tkinter, Tkinter, which is helpful in creating combo boxes or drop downs or list or labels or buttons. So you can do any kind of a front end programming using Python. Then there is something called web maps and plotting. So if you want to work on real time Google Maps, suppose you want to find out latitude and longitude of a particular place, or if you already know latitude and longitude, you want to figure it out what location it is. You want to figure it out what are the most accident prone areas in the particular country. You want to figure it out what are the most prone areas where volcanic eruptions are going to be there, or what happened in the past, or where is the crime rate very high, or where the traffic is very high. So you can do all kind of a geostatistical kind of information using web maps. And there's a library called Plotly, which is helpful in getting this done. Or there's another library called OpenCV. OpenCV library is helpful in doing web maps and plotting it. And then comes OpenCV using Bokeh. So the Bokeh is another library which is helpful for data visualization on the map site. So this is generally a kind of a roadmap wherein you are going to start from the beginning of what is Python till the end. And then next part comes the machine learning, that is predictive analytics. So once you understand all these things, then comes machine learning. So machine learning is, you can think of, requires a prerequisite to get all these things done, because machine learning is the final step. Before that, we do a lot of data wrangling, munging, cleaning, concatenating, analyzing, plotting graphs. And when machine learning comes, we assume the data is accurate, 100% accurate. There is no outlier in it. The data is completely clean, so that once you do the prediction, you can be sure of it. If your data is not clean, it is having outliers, then you cannot rely on those predictions. So we need to be 100% sure that predictions are going to be right. Steps involved in predictive analytics. If you talk about steps involved in predictive analytics, we follow systematic process for predictive analytics. First of all, we do data exploration. Data exploration means analyzing the data, how it looks like, what are the different fields in it, what are the different data types in it, whether outlier is there or not, whether all the columns are numerical or not. We explore and analyze the data. Then we do data cleaning. Once we explore the data, we come to know where are the outliers, where are the missing values, where are the correlations, where are the variance. And we clean the data by removing the outliers, by removing the comma, removing the dollar symbol, removing the special characters. We do a lot of data cleaning. Then we do modeling. Modeling means we pick up any analytical model, predictive model like linear regression, logistic regression, decision trees, random forest, naive-bayes classifier, support vector machines. We pick up any model of our choice, and then we do performance analysis by checking that model whether it's working fine or not, whether it's predicting well or not. So these are the four major steps that we do for the predictive analytics. Now, data exploration, as I told you, data exploration is basically understanding the data. As I told you, we need to understand the data completely, how it looks like. Then data cleaning means data cleaning is used to get rid of redundancies in the data by removing the outliers, removing the common records, removing the missing values, finding the variance in the column. It has to be high. Finding the correlation between the columns, it has to be high, it has to be low. If two columns are highly correlated, it means they are depicting the same information. So we clean the data, and then we do data modeling. Data modeling means selecting the model on the basis of what is important for predictive analytics. So different model is having different use cases. For example, linear regression is used when the dependent variable is continuous in nature. Logistic regression is used when the dependent variable is categorical in nature. So we use data modeling technique to pick up which model is going to perform well. And then finally, we do the performance analysis in terms of how the model is performing. After building the model, analysis of the model is necessary. So whether the model is effectively doing predictive analysis or not, whether the predictions are accurate or not, we figure it out. And once we know that the model is 100% accurate or near to 100%, we can deploy it on the server. If we talk about predictive analytics using Python, we make model to predict price of the house by the housing data. Suppose you have a historical data about houses. Price of the house depends on locality, number of rooms in the house, area of the house, number of railway stations or metro stations nearby, number of markets nearby, number of schools nearby, people teacher ratio, atmospheric, or we can say pollution in the particular area. So house of the price depends on many factors. So we can use linear regression model to predict the price of the house based on historical data. Suppose I give you last 20 years historical data about the prices of the house, you can easily predict what is going to be the price of the house in the upcoming future. So this is one of the applications of it. Thank you all of you guys. Thanks for your time. Have a great day. Bye bye and take care.